Today, we are in topic 9, block 10 of probability. We are developing a probability model today and using the model to find probabilities. We're going to represent sample spaces for events, make predictions based on results from experiments or theoretical probabilities, and we're going to find the probability of compound events. So, looking at page 9, Devin, if you don't mind, go ahead and read that for us, and then we're going to answer some questions.
The whole thing, or it's highlighted?
Everything.
Consider another game. You and your partner each have a container. Each container contains the same number and type of marbles: 2 blue, 1 yellow, and 3 green. You and your partner will each set 1 marble from your container without looking. If you both choose the same color marble, you will both win prizes. Conduct an experiment and determine an experimental probability. Then play the animation to determine the theoretical probability.
All right, so looking at this. If you look at their jars, they both have how many marbles in each jar?
6.
All right, and how many of each color?
3 green, 2 blue, and 1 yellow.
Perfect. So, Vincent, what do you think, which color would be most likely to be picked by both of those kids? Green. Why?
Because it has the most marbles.
Okay, in each one. All right, and which one, Laura, do you think would be least likely to be picked?
Yellow.
Okay, so based off of what we got set up, a while ago we performed an experimental activity. And so what we did was we decided to set up an experiment similar to what they had, and we tested our own results. So what we're going to do is we're going to compare our results with their results. So let's see what theoretically could occur. All right, so looking at this, if the first person was to draw, how many scenarios could they get? What could they get out of these 6 chances? What would be the chance that they would pick blue?
2.
All right, so there's a 2 out of 6 chance that we would get blue. What about yellow?
1 out of 6.
Perfect. What about green?
3 out of 6.
3 out of 6.
Awesome. So, what do you think would happen if we were to set this with the second selection? How is this going to change? What would be the chance that we would get a blue?
4/36.
Correct. Can that be simplified?
1/9.
Perfect. How'd you do that?
Divided each section. I divided 4 by 4, which got 1, and then I divided 36 by 4 and got 9.
Perfect. All right. What about our blue to yellow? What do you think, Alora? What's the chance we get a blue to yellow?
2/36.
Correct. Can that be simplified?
Wouldn't it be 1/18?
All right. How would you get that?
I divided 2 by 2, which got 1, and 36 by 2, which got 18.
All right. Let's look at blue to green. What is the chance of blue to green, Brendan?
You said green.
Blue to green.
636.
Good job. Can 636 be simplified? What can we divide 6 and 36 both by?
6.
Correct. 6 divided by 6 is?
1 6.
Good deal. And 36 divided by 6 is 6. Good. Let's look at yellow to green. What is that chance, Sanaya? Oh, yeah, she can't hear us. Let's see what she wrote. I mean, she can hear us, but she can't talk. Let's see what she got. Sanaya hadn't said anything yet. Help her out. Go ahead, Devin.
It would be 336 that you
Correct.
can actually what is it called?
Simplify or
Yeah,
reduce?
simplify. It's 112.
How?
3 divided by 3 is 1, and 3 divided by 36 is 12.
All right. What about our green to green? What do we got there, Angel? Help her out, Akira. What is it going to be?
Would it be
How many green greens do you see?
9?
Yeah, 9 out of 36. Can that be simplified?
Yes.
All right. What can I divide them both by?
9.
9 divided by 9 is?
1.
36 divided by 9 is?
4.
Good. All right. Let's look at the next one. What about our green to yellow?
336.
Correct. And we already simplified that earlier. We said that would be what?
112.
Perfect.
And then green blue, wouldn't it be 1/6?
Yeah, because it'd be 636, which would be 1/6. And we got yellow to blue, which is
236,
and we
which
already
would be the same as 1/18.
perfect. And we got one left, the yellow to yellow.
136.
All right, so were we pretty much on par with our predictions earlier whenever we said that we thought green would more than likely occur the most?
Yes, sir.
Theoretically, it's going to. It's got a 25% chance. That yellow to yellow is a what chance?
1%.
Yeah, pretty close. All right, and it's like not likely at all, is it? It's the least likely. Okay, so let's take a look. So we said that green was the most likely to occur. Yellow to yellow was least likely. And so I don't know why these are brighter, but I guess they're just trying to show a little bit of difference from them. But we know that yellow to yellow is least likely and green to green is most likely. Now, we were supposed to conduct an experiment and determine the experimental probability. So what I want you to do at this time is I'm just going to pick on each group, and I want you to tell me your results for what you got for blue to blue. So what did y'all get, Devin? How many blue to blues did y'all get out of your 20 trials?
I think we got 3.
All right, so y'all got 3 out of 20. Okay, if you do 3 divided by 20, what do you get? Like percentage-wise?
Actually, we only got 2 blue to blues.
Okay, so we're going to do that. 2 divided by 20 is
On mine, it was 3.
10%. All right, so this is 4 out of 36. Let's see what that So it's 11%. Was the theoretical probability close to what y'all's experimental probability was?
Yes.
Yes. Vincent, what about y'all's blue to yellow? What did y'all get?
I don't think we got any.
All right, so that makes sense. That's why it's not coming up on my computer right now. So blue to yellow, if we do 2 divided by 36, dadgummit. She's not wanting to work for me. 2 divided by 36 is 1/18. 1 divided by 18 is what? Anybody know? What would that be as a percentage? I'm trying to pull up the phone to do it at the same time. 1 divided by 18. I got 5%. So Vincent said he didn't get any at all. So we were pretty sure that that was not going to occur much at all, right? So I would still say that was beneficial for us to know. On the blue to green, what did y'all have, Brendan? Help him out, teammates. What did he have? What did y'all have, teammates? All right, well, I'm going to another group. Akira's group, what did y'all have for blue to green?
1.
1. All right. And it was a 6 out of 36 chance, which was 1/6. And so 1 divided by 6 is what? Y'all are slowing down on me. What's 1 divided by 6? What is that? How many percent would that be? Come on, class, let's participate.
16%?
Yeah, 16%, 17%, it's right there, okay? So, based off of what Vincent said, he said did they get 2 or 1? What'd they say?
1.
All right, so 1 divided by 20 is 5%. So it occurred a little bit more often in our theoretical probability, right? That's okay. What about yellow to yellow? Is there any group that got a yellow to yellow?
We got 1.
Got 1. All right, so 1 out of 20. If you were to divide those, you're going to get 5%. Okay, and so we got 1 out of 36, which it's not even going to show because it's that low. All right. So the percentage was very low. And so, with that being said, we knew that yellow to yellow was most likely not going to what?
Occur.
Mm-hmm. So if we were playing a game and we wanted to win, would we pick yellow to win?
No.
No, not at all. So there's a game, and trying to think what it's called. But anyways, like I'm sure y'all have seen movies where people are gambling, and I can't think of what it's actually called, but they have like a marble and they spin this thing around and they throw the marble into it. And so
I've
there's
heard of it, but I cannot
yeah,
remember
I've seen
the
it on a
name.
movie. I
I've
just
heard
can't
of that.
remember what it is. But anyways, they drop that marble in there and it spins around and it finally lands in a spot. And so there's like a 1 out of 36 chance that it'll happen on certain colors or certain numbers. And so, these people that gamble, if, say, for instance, they said, I got $100 on this one that's got a 1 out of 36 chance, and people do this the same way with horses also. If that, which you got to have a lot of money to waste first. But anyways, if they did this and they won, and they had put $100 in it, well, they win 36 times 100. So they would win $3,600 if it landed on it. Is it really likely that they would win that, though? No, not at all. It's a 1 in 36 chance. So, more than likely, anytime you gamble, especially in that situation, they're going to do what?
Probably go for the most likely.
Well, they would go for the most likely, but if they were these people and they chose to do this,
They'll lose.
they're going to lose their money. And trying to teach y'all something early. If you gamble, most likely you're going to lose your money. So keep your money, do what's right, and you'll be better off.
Mr. One,
Yes.
I think I know what that thing is called.
What is it?
I think it's called a roulette.
I think it is too. I just couldn't remember exactly what it was, but it's a pretty cool looking deal.
Yeah.
All right.
Well,
So
I just round mid thing.
yeah, it is the round thing that you spin and then drop that marble in there. It's cool looking. I won't ever
it's
play it
sort of
because I'm not wasting my money.
It's patterned. It's patterned like a dartboard, isn't it?
Yeah, sure is. All right. So our green to blue, what results did we get on that? How'd y'all do on that?
Me and Angel, we actually got 4 of those.
Got 4 of them, and we had a 6 out of 36 chance. So if we do that, that was a 1 divided by 6. I think we said that was a 16% chance. Y'all said y'all got 4 out of 20, which was right at 20%. So that was pretty close, right? Green to green. How often does that occur?
Me and Angel got it twice.
All right, y'all got it twice. Did anybody get it a lot more? Y'all had some.
We just got it 3 times.
Wow.
We got green blue the most.
Really?
Green blue.
That's interesting. So, were all of your objects exactly the same size?
Yes, sir.
Hmm.
Mine were at least.
That's interesting.
When I did up to scissor things,
Yeah,
and I just folded up the paper and did it like big circles.
I got you.
Put it in my crayon box.
I got you. That works awesome. Okay, so that's pretty interesting. In my other classes, we were like dead on 25% for that. One class, they ended up getting it 45% of the time. So y'all were a little bit lower than how those other ones went, but that's perfectly fine. And that's why it's called theoretical probability. Is it always going to happen?
No.
No, it's not always going to happen. It's just basically something to help you so that you can possibly win a game of chance. Okay? It's just something to help you. So looking at this, we said at the beginning, if we wanted to find this without using one of those area or an area model, we can always just multiply because it's a compound event. And so what we do is we take the chance that it would happen first and take the chance that it would happen second, and we multiply it together. So the odds that a blue to blue would happen is a 436, which we said earlier was a 1/9 chance. Now, I honestly think that multiplying and using our first selection and second selection gives you your answer way quicker than an area model. I feel like I would mess up an area model. I think that multiplication, I know how to multiply, so I do good at it. If y'all feel more comfortable with the area model, use it. If you don't feel more comfortable with it, use multiplication. Okay? So we got visual learners and we got people that learn from lecture and just from doing things. Okay? So if you're a visual type learner, draw a picture. If you're not, just knock it out. So we're going to take a look at page 10. Looking at page 10, if you would go ahead and read this for us, please, Alora.
Use what you have learned to determine the probability of both students choosing a green marble from the container. Can you solve the puzzle to find the theoretical probability of both students randomly drawing a green marble?
All right, so looking at this, what is the chance that you're going to get a green marble out of that jar?
3 out of 6.
Okay. What is the chance that we will get a second green marble?
Mr. One, I said 3 out of 6.
Oh, I messed up. I'm sorry. That lady kept talking. She messed me up. All right. What about the second selection?
3 out of 6.
Perfect. Now, that dot right there in the center means that we need to do what?
Multiply.
All right. So remember, when multiplying fractions, we multiply straight across. What's 3 times 3?
9.
And what is 6 times 6?
36.
All right. Could this be simplified, class?
Yes.
Yes. Do we have to for this?
No.
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 That's why it's important for you to know how to do it both ways.
Because there's not a 4.
Correct. All right. Now, how are area models helpful for determining theoretical probabilities? How are area models helpful for determining theoretical probabilities? How did they help us a while ago? Instead of multiplying, we were able to do what?
Divide.
What did the area model do? That was the thing that we saw on page 9.
It helps us section the parts.
It did. It helped
Like-
us section the parts to where we could do what?
We were dividing. That's why I said divide.
I got you. You're saying you divided it into 6 parts. I understand what you're saying, Angel. What I'm saying, though, is how does it help you? What does it allow you to do?
Like divide your sections up.
And then when you divide your sections up, it allows you to see what? All of the possible.
All of the possible.
All of the possible outcomes.
Perfect. Perfect job. All right. So this is actually going to conclude our lesson. However, y'all need to go right here to that arrow and you're going to click more practice and you're going to answer questions 21 through 23. Now you're going to have to answer these by using what we learned today, dealing with compound events. We said when we use compound events, we're going to have to do what operation?
Multiply.
Multiplication. All right, my boys and girls, I hope y'all have a fabulous day, and I will see y'all on the next round.